morning.
Welcome back to Structure.
Thanks. Always happy to be here.
So you guys invest in a lot of different areas, as we've been talking about a lot. And obviously for Structure today, we're pretty much focused on the enterprise. So one thing I wanted to ask you is, we see so much investment activity in so many different areas of the tech industry. Why do you think there's not as much investment in some of these enterprise areas? Some of the hardware, chip technology related startups?
Well, it goes in cycles. If you look at the lines on the side, not enough room here, filled hole. I think there's a cycle of innovation going on, which then leads to a cycle of investment. So I'm pretty optimistic there'll be a lot more interest in this area. Some marquee offerings like my friend Andy Bechtolsheim's new company, Arista, really starts to get the ball rolling. There's a lot of exciting companies in this area. We investors in Nutanix is doing really, really well. So once you get a couple of role models, investors tend to follow.
So what has changed, though, to generate that business activity, that cycle almost?
If you look at the history of computing, leaving aside the mobile endpoints, the client-server architecture sort of stuck with us for a long time. And there was very little either interest or capability to innovate. I haven't seen a new architectural innovation from an IBM or a HP or a Dell, and I'm going to get some nasty phone calls, in 20, 30 years. So what Sun started sort of evolved a little bit with Linux and others, but innovation in computer architecture fundamentally stopped. And then this thing happened on the side. Google started innovating. Everybody wants to be like Google in their cost structure, or Amazon did a great job with AWS, and Facebook's doing interesting things. So they've invented a new way to doing things. I don't think Google talks to Cisco about getting its networking gear. I don't think they even look at those product lines. Largely irrelevant to the new architecture. New stuff like Azure might use an Arista networks or something like that. But giving everybody else the benefits of what Google and AWS are doing for themselves is a massive opportunity for all of you to innovate and start new companies. And I think we are starting to see the beginning of that.
So what precisely was it that they did that opened up this opportunity? Was it we've been talking a little bit about, back 10, 15 years ago, we were all concerned about processor speed. Then we started getting really concerned about power efficiency. And now we're talking about a lot of different things, including adaptability and the tendency of large companies to design and make their own infrastructure products, as we saw with Facebook this morning. So what brought that about?
Something fundamental I think has changed. Used to be you bought end-to-end infrastructure and a single person to blame kind of approach to enterprise buying. What has really changed is the rate of change. When the rate of change increases, and it has been increasing in my view, not just in architecture, but in the business. What businesses work, what doesn't, does one Facebook application take off versus another, Instagram suddenly happens, Snapchat suddenly happens, and the same is happening in a smaller way inside the enterprise. What changes is sort of old engineering habits. As an engineer, I was told to optimize for performance or optimize for cost. Some very, very specific things. In fact, I think we have to re-engineer engineering itself to optimize for change.
What do you mean by that, though, optimize?
I mean, when you optimize performance or optimize cost or peak loads or whatever you're optimizing, you're assuming you know what you're optimizing for. If the rate of change is high, I argue, you really have to optimize for not knowing what you're going to be facing a year from now. The world changes so rapidly, stop optimizing, optimize for change and adaptability and agility. And you suddenly see a whole slew of opportunities pop up.
Well, what are the things that people are doing to prepare for this change, to get themselves ready for it?
So you see isolated buzzwords that are very, very key to this, and I think directionally real. You see this idea of software-defined networking, software-defined data centers, software-defined storage, software-defined compute, SDX. But what SDX is really doing, if you think about it, it by itself is not very useful. What's useful about SDX is it's an abstraction layer that lets you build applications on top without having to go re-engineer stuff, re-plug this cable into that. So what to me SDX is really useful for, and a real opportunity for all of you, is it increases the rate of innovation by providing an abstraction. There are other things like this going on. Jay Parek was talking about top-of-rack switch. I find that exciting. What happened in open computing, like little pods showing up in computing, is modularity. But modularity itself, why is it useful? It's only useful if it allows organic growth. You have no idea how much you need. You don't have to over-facilitate. You don't have to over-provision. You just take it as it comes and rapidly grow. So each of these are really indicators of a major need. If you flip the stuff around, what you're really saying is customers don't have a clue where their business is going to go, so let's build the systems that let them respond. Instead of saying, hey, let's build a plan for 3 years from now or 5 years from now. Say, it doesn't matter, don't plan. Plan not to plan, but we plan to be really agile. And that, I think, architecturally leads to a whole set of decisions. SDX is a symptom of it, modularity or these pods or top-of-rack switches that are open, all are symptoms of the customer's problem.
So what are the technologies that are going to allow people to adapt for this change? I mean, we've heard a lot of talk about things like containers recently, and I'm really more interested in hearing what you're betting on from a technology standpoint as opposed to a specific company.
So, to me, SDX really is architecturally changes the way we approach data centers or enterprise computing. But the really interesting thing is not SDX, and we have big switch networks doing that, and we have other companies in that whole area. What's interesting about it is new applications it enables. So let me talk about my all-time favorite app that nobody's really talking about. If you switch the problem back to the enterprise customer, what are his problems? If you looked at any IT budget, the largest piece of it is cost of ownership. The equipment they buy, what vendors sell them, hardware, software, tiny slice, looks like Pac-Man's mouth, if you remember that game from the 80s. The rest of it is cost of ownership, the big cow, I call it. Now, if you got rid of that big cow, it'd be a massive opportunity. How do you do that? It's IT people mostly, get rid of the IT people, get the human out of the loop, autonomic systems. We've talked about autonomic systems with machine learning applied not as an application outside, but to IT and making it self-optimizing. You suddenly have a massive opportunity. So if these systems, we use the word adaptive, but it's really saying take all the data, it's next generation Splunk is what I call it. Take all the data these systems are putting out, whether it's log data or network data or snooping on the network, traffic data, use it to build adaptive systems. They have human judgment like systems built in that decide what to do. You certainly don't have to worry about hot data or cold data. Who remembers what was hot and cold a year ago? Among the 500 different apps you're running in your data center, it's ridiculous to have humans manage the level of complexity that we have humans manage inside the data center. So the best way to take the biggest cost out of the system, the biggest entrepreneurial opportunity, is to eliminate humans in the loop.
Just take all their jobs away.
Well, it's happening everywhere. Other jobs will show up. But the fact is, IT is a big cost. People is a big cost in IT, not equipment and software. Let's take that out. That's a massive opportunity. When you go to AWS, you're sort of taking out IT. When you go to Azure, you're taking out IT. All I'm saying is do it for the enterprise too.
I wanted to open it up for any questions from the audience. If anybody has a question, we've got mics on either side. And if we're waiting for somebody to come up, I just wanted to ask you a little bit.
Well, let me, while we're waiting for questions, give you a little bit of a perspective. Almost everywhere I look, if you stop linear extrapolation of what we've done, you see great opportunity. You sort of say, instead of, hey, Hadoop, how do we make Hadoop a little faster or better? What does the customers need? Right? It's big amounts of data. I find it silly in this day and age to be running Hadoop. It's a batch system. I thought Sun took that out in the 80s. And then if you're a product manager at Procter & Gamble, what do you have to do? Get requisition a programmer for MapReduce to get a query done instead of doing 100 queries the first hour? So you invert the problem and say, what's the opportunity? Is it Spark? Is it something like that? I suspect so.
How are you positioned with respect to those?
Well, we keep looking, so any of you have great ideas, send me an email, vk@khoslaventures.com. But if you ask a different question, you get two great answers. I talked about IT infrastructure. If you look at what Google's working on, it's like Omega is their data center scheduler. We are all talking about OpenStack, and OpenStack's good, but it's still humans doing management. If you make that real time, it becomes Omega or Mesos or one of those kinds of schedulers. Now, there's things that have to be done at very fast scale, so you can't have humans, so you do Omega or Mesos. There's things that can be done slowly, you call that management, but it's the same. It's managing resources, allocating resources. That's what an operating system does in a computer. That's what a data center operating system should do. It's an opportunity.
I think we've got a question over here.
Hi, I'm Paula from Pivotal team. I have an interesting question on what the past market should be and how it is, and what do you think about Cloud Foundry in general?
What market should be?
Platform as a service market.
Yeah. Look, I think platform as a service is valuable. Infrastructure as a service was valuable, and it still is valuable. But what was the point of it? It's you want all the benefits of a dedicated machine and the scale-out simplicity of a cloud. Now, you can do that at the infrastructure level. You can do it at the platform level. In the end, Mark Fleischman likes to say everything as a service is sort of his term. Right? Yeah, the example he would give is you don't do provision 100 terabytes of data in X VMs. You say, here's what I need for 10,000 users. And sort of do it for me. So I think the general trend is the more you can virtualize without too much of a penalty and cost or performance, I think that's the goal. And the better the technology goes, the further up the stack you can go in that.
So I'm sorry, was there a question up front?
Yes, thank you. Mike presenting with Camp Mark. Mr. Khosla, in an environment of incumbent operations, how do you believe innovation will happen? Primarily on the hardware side, we're going up against very big players in trying to define this software-defined X or hardware-defined X.
So the question is, how do you do this innovation in the face of incumbents? Incumbents want to lock you in because that means high margins. Just look at high margin vendors and don't buy anything from them. Right? Simple answer. But but let me be a little more serious, right? If you take something like your network, you probably have L3, L4 switches, that kind of stuff. Services like big switch networks actually will encapsulate some of that stuff and let it work with the new stuff. You don't throw the old stuff away, you encapsulate in some way. In fact, there's a paper on my website I wrote about 15 years ago called the Real-Time Enterprise. And the notion is, for old stuff, you have to encapsulate, because you can't throw it away. But for new stuff, it's interesting, you not only do these new technologies, but when you install them, you plan obsolescence. So if you run a network, specialized functions are becoming a problem. Hardware to do SSL. So the new buzzword is network function virtualization. It's really a way to plan obsolescence of a technology when you do it. And I think that's an important way. I think the stack keeps moving up to the earlier question of platform as a service. Today, even database services will end up as a service. So we have ParseStream, MemSQL, MetaMarkets, all doing various types of workloads, database services. My favorite one is one called Realm, where if you're doing your mobile phone and using native data structures in your programming language, all the database and cloud functions happen in the background. You don't even need to know about it. But all kinds of interesting things like that going on. Like I said, innovation's almost everywhere, and we keep looking, and pretty aggressively.
I'm afraid we're all out of time, but thank you all very much.
Thank you.